Okay, this video is gonna try to explain a little bit where I'm coming from with some of my ideas. Now what we have here is the golden ratio spiral. And the way I was thinking about the universe is that it doesn't matter the size of something. It doesn't matter the size of a planet or, the size of a grain of sand. The matter that makes up the material keeps in perfect balance with the universe. Because when you think about it, if it wasn't in perfect balance, what would happen to things? We wouldn't have matter. It would either be imploding in itself or exploding all of the time. So it can't be that way. It has to stay in perfect balance. Otherwise, nothing would be here. So the way I see it is, how does it maintain perfect balance? Let's say this is the biggest planet over here. And as you get smaller and smaller and smaller, it keeps in perfect balance, and you could go all the way down to the quantum level. The smallest thing ever. Where eventually the laws break down and it changes. So where was I going with the 5 divided by 3 numbers? Okay. 5 divided by 3 equals 1.666 until infinity. I see that 1.66 until infinity as being this curve, okay? Let me bring up another picture here. That's the curve. Now in this picture, we have things that are totally different. We have a curve, this is curve, and completely opposite, we have these straight lines. Two totally different things, curves and straight lines. Is the earth round or flat? It's both. It's not one or the other. It just depends on your perspective. Okay, so where do I get 5 divided by 3? Well, take a look at this star. How many points does it have? 1, 2, 3, 4, 5. How many of those points are touching the curve? 1, 2, and 3. Now, I see these points here as being positive, negative, and neutral energies. And I see this curve as being the fabric of time and space, the curvature of time and space. So this is why it's such a big deal. It's the unifying theory. Okay, I think most people that are trying to find the theory of everything should probably think hard about what they're trying to find first. Because I don't think most of them, I don't think they have the foggiest clue as what that really means to explain how everything works. So that's how I'm seeing it. This is how everything remains in perfect balance. And it's kind of hard to describe because this is a 2D picture. But I think that, this is going on in multi-dimensional frames. If you could picture this star as being a 3-dimensional object or 11-dimensional object. So say you have a particle right in the middle, smack in the middle. And let's say that there was an energy trying to throw everything out of whack and out of balance. Let's say that this was going to leap out of here. And that's what I would think that would, if things were always imploding, that's what would happen. You know, it wouldn't be able to hold its structure. It wouldn't be able to maintain its stability, and it would implode or explode. But I think what happens is, let's say it was getting to this point. I think every point on here, say if it was going to get over here, the energies on the opposite side will always be twice as great and maintain that balance. Okay? Just from the shape of it. Okay, if it was going to get to that side, whatever, positive or negative, it would bring it back. You know? If something started to get a little bit too negative, the positive side would bring it back. So, alright, let me see if I could find this other drawing that I was trying to explain really quick. Because what I think is going on here is we could use this to our advantage. We could use the quantum vacuum to our advantage. So we don't have to do all the work. Alright, let me see if I can find this other paper. So this is a little design that I was thinking of to exploit this. Let's say you had a cone, right? And you had ball bearings on the outside of the cone. And you have attached to the ball bearings magnets. Okay, that's what I'm trying to make those little squares to be the magnets. I only made 2 of them, but let's say that the ball bearings and the magnets were all around the inside of this thing. And let's say you had some kind of device holding them. Let me see here. But what I'm trying to say is, let's say at the top here, these magnets would be fine where they were. That would be like the resting point. What I was trying to draw here was just say, like some kind of connecting device connecting the magnets. But let's say you had a hole in the bottom, and you could pull the magnets down. So if they were up here being at the resting point, now let's say they got down here and they were too close for comfort. They didn't like being that close to each other, and they would try to start pushing off each other. So if it was equal on all sides, I made this other picture here. Let's say you were looking at it from the top view. I'm gonna get focus. Let's say you were looking at it from the top view, and that was the hole in the middle, and these are the magnets. Say if the magnets get closer to each other, they would repel, pushing against the side of the cone. And you can use that quantum vacuum to your advantage, because it would be just like a toilet bowl flushing. The water has to go and spin in one direction.